Welcome to my channel. Today, I'm kicking off a new series where I'll be converting a Onewheel XR to a VESC controller on the cheapest way possible. If you are looking for an affordable way to fix your Onewheel and get it back in action, you're in the right place. The VMS in my Onewheel has a bad communication port, therefore the whole board is dead. When I press the button, it doesn't do anything. So I'm going to use the VMS anyways, since it can still charge and balance the battery pack. The method I'm using for this build is called VMS bypass, and it's basically taking the power straight from the battery pack to power the controller. I'm going to show you the process of this build start to finish. So if you're planning to do your own build, I hope that this video serves you as a reference. I've also made a wiring diagram that you can check on your phone or your tablet, and you can download on the link on the description. This diagram is specific for this build. However, most of the VESC conversions and the VESC controllers has a similar inputs and outputs. So check it out and it may serve you as a reference. I'm going to use as many stock parts as I can. This build requires some soldering skills, but if you are a DIYer like me and you think you can do it, I bet you can totally do it. So let's dive into part 1 of this series and start this exciting journey. So the step number 1 is taking all the battery box apart, removing the battery, all the connectors, so we can pull those connectors out from the battery box to start our harness process. This is our harness without the tubing. So you can see this is the cable they use for charge and discharge, and it's a regular 12 AWG, which is interesting because 12 AWG is only capable of 20 to 30 amps max. And what I'm gonna use is 12 gauge, but on silicone. Silicone cable can handle more amps. Okay, according to this chart, 12 gauge silicone cable is capable of 88.4 amps. I get why they use this cable, because maybe their BMS can only handle that kind of amperage, maybe only 30 amps max. Otherwise this cable will melt. But because now we're gonna basically plug straight to the battery, we can pull a lot more amperage than that with the same battery, because we are not through the VMS. Fitting these two cables here. I passed the main cables through the harness connector, but that's actually a bad idea. Just ignore that. I'm gonna do it in a different way later and explain why later. Next step is gonna be taking those apart. I'm gonna reuse these same connectors. 14 gauge cable, silicone. 12 gauge silicone cable for motor connector. 4mm bullet connector, male side. This is the connector for the hall sensor. So the red is 5 volts, the white is the temperature, this is ABC for the hall sensor, and ground. And same thing for the footpath sensor. Kilo ohms pull down resistors that they're gonna be in parallel to the two sensor inputs to the ground. Okay, I changed the plan here. I'm not going to pass the cables through that because if it's time to do maintenance and take it apart, it's gonna be a nightmare because this is gonna be all together and it's gonna be all close. So instead, I pull the cables and I'm gonna add a X290 connector, and the only place it will kind of fit is beside the motor connector over here. Other thing is that I removed the button. So let me show you what I'm gonna use. I'm gonna use this VESC. This is the cheapest VESC available, I think. This is a Flip Sky 75-100. I use this for another project, and this thing can do 100 amps continuous and like 150 max. Trust me, I pushed that thing so hard on another project. Actually, let me show you here. This is my disaster. You see that bike with that motor over there? Yeah, it drives that, and it's really torquey, really good. I'm gonna use it because I already have it. But if you're gonna get one or you're gonna do the same thing, I highly recommend you to get like the U-Box 100 or something like that, because I think this is like $70 on Amazon, but you gotta get like a Bluetooth for it, and this is like another $20. And then you gotta get the IMU sensor, and the U-box it already has the IMU sensor integrated to the board. Another thing that you can do with the U-box is that you can use your switch. This is not compatible with power switch. You gotta get like they sell like a separate power switches, anti-spark power switches, but I doing this the cheapest way. So what I'm gonna do is I'm gonna make like a a key connector. This is a ST90 anti-spark. I'm gonna install this one here, and this is gonna be like my key. This is gonna be only in the negative cable. This actually cut the power entirely from the battery, so this is gonna be like here. I'm going to start modifying the controller box to insert these XT90 connectors. Let's add our XT90 here. That is gonna connect to the controller box. Okay, it's a moment to soldering back the connectors. Mark your positive and negative sides because this is backwards. So yep, just keep that in mind. It's very important that you have the right polarity. Otherwise, you will make a huge short. Battery plug, and this is gonna connect here. So it's negative to negative to negative, positive to positive to positive here. So this is gonna feed straight from the battery, feed that way, and the BMS. Let's take a closer look. White cable. Always mark that this side is negative to match the battery polarity. Okay, battery box is ready, so we can close it now. Here we go. That's the main connection, and then the balance connection. What? I will pay you later. Okay, so I had an idea here. I'm gonna mount that one like that, but since this is the only piece of aluminum that dissipates the heat, I got this piece of 4-inch aluminum that I'm going to install here, and I'm gonna attach these two together. I'm gonna cut this a little, I'm gonna trim it so this part will stay basically on that gap, and it's gonna be showing on this side. That way the airflow can hopefully dissipate the heat better. Couple things I did off camera. I removed the LED status and I extended. I'm gonna push this LED into that gap. I connect this pigtail. This is a JST connector that will give me battery voltage to supply voltage to the LED. I'm gonna connect that to a step down module. So I'm gonna attach this block here. Use a little bit of heat transfer paste. It's time to start putting the controller box together. We already have most of the connectors. I'm going to use ultra-pure silicone. So this is a LED tester. Let's see what's the voltage that we need to power the front LED. 13.9 volts. The red one from that's going from the back here. That's 7.7 volts. I use two of those step down DC converters. That's taking the full battery power, 60 some volts, down to the red ones, 7.4 volts. You're below 7.4, they're not gonna turn on. And the white ones, about 13.3. I'm gonna plug here the white ones. By the way, I also desoldered the connector for the lights, for the front lights, so I can plug it straight to the connector here. Alright, first connection. So remember, this is always hot now. This plugs here and this plugs here. Okay, yeah, nothing gets power until I connect the key. So here we go. No spark, good. We have the LED lights. We should have our green light there. Let's check on the app. Oh, it's not the one. It's the VESC now. VESC. Is that one? Yep, it's connected. Okay, I secure with silicone and double-sided alien tape all the parts that can be loose. If you get an external IMU, make sure it's really secure in place. Okay, it's time to close the controller box. I cut all the bolts that were sticking out and use a piece of insulating paper. After that, we can assemble all the board. Now let's do a makeup to this board with my custom rim and rail bumpers. I designed this 3D print part for the XT90 connector, so it's more practical and looks good at the same time. That wraps up the build for our Onewheel VESC conversion. In the next video, I'll show you how to set up and program all the parameters in the VESC controller tool to get everything running smoothly. Stay tuned for part 2, where we take this project to the next level. Thanks for watching, and I'll see you in the next one.